Good afternoon, everyone. First and foremost, I would like to thank you for spending your time here with me and listening to my talk. I don't take that for granted, and I really appreciate it. So what am I going to talk about today? Minimum Viable Security, aka MVS. MVS is basically a methodology about security. How can I incorporate the minimal amount of security measures while giving ourselves, the developers, maximal amount of security? How can I incorporate as many security measures while not damping our velocity? So what is MVS? A minimalist approach to security, minimal amount of security overhead, maximal value, while supporting dev team velocity. I always like to think of it as your personal health. Imagine going to the doctor's office, and the doctor will ask you, how healthy do you want to be? A bit of a void question. Healthier, healthiest, perfect health. No chance. We strive to be as healthy as we need to maintain our existing lifestyle or potential lifestyles. Security should be the same way. We should be secure enough for our needs, for our clients, for our technologies, and not pursue some bizarre perfection of security. So, who am I and why am I here? When I say why am I here, I don't talk specifically about PyCon. That's because someone else canceled. My name is Michael Segal, 30 years old developer from Tel Aviv. And I've been a Python developer for the past 5.5 years, a Django enthusiast. Flask is okay. And I've joined Git and the cybersecurity industry. It's my second job within this industry because I care. Because I decided I want to solve a meaningful problem and to help people do their work in a secure way and eventually give their clients a secure product that they can use without major cares. One of the reasons that made me really want to join is one of my previous employers, I won't say the name because it's not a very flattering story, had this constant fight between dev and security. Dev teams wanted to be fast, velocity, features. I feel like Steve Ballmer, developers. While the security team, on the other end, just wanted to make sure there's no CVEs, no CPEs, everything is secure, everything is wonderful. And we couldn't find the same language. And we tried for several sprints. And then when I moved to my first job within the cybersecurity industry, I said, I'm going to create a bridge between those two departments. I'm going to talk in a language that my CISO understands and my developer understands. And now I'm part of Git, who tried to do an even bigger revolution. And the last and the single most important reason I'm here is you. My single goal from this talk is that if there will be a single person in this hall that will be a little bit curious, adventurous, brave, to try and be the security champion of your own organization, there will be no one happier than me. And eventually, your clients. So when we talk about MVS, let's try to be a little bit more specific. You're trying to protect your app. Just like you're protecting your house, let's start with the door. Let's start with the perimeter. So what do we have in almost every app? We have public resources, endpoints, buckets, and you can think of a billion different entities. How do we handle that? Well, cloudless configuration and pen testing. Continuously, all the time. It's not a 1-month thing in June, and then in November you say, everything's good. Your CI/CD pipeline, least privileges. Once you incorporate something as big as a CI/CD pipeline into your dev team, day-to-day actions, you don't just give it every single permission. You need to give it the minimal amount it needs to do its work appropriately. User access, the single most dangerous thing in every app. MFA and least privileges. We need to make sure they are who they claim they are. And they can do exactly what we want them to do. For example, role-based access controls. And third parties, very similarly, MFA and scope. Once we incorporate tools into our product, let's make sure we don't give them just general access to every single thing. That's where problems and expensive ones begin. So we talked about the outside. Let's talk about the inside of the app. We've got a lot of traffic. How do we handle traffic? Encryption. There's no reason in today that your public endpoints won't be on HTTPS. There's no reason to supply a token with a request. There's no reason not to encrypt your data. Secrets. Use secrets managers. I always like to say that point. Don't try to create your own secrets managers. There are great tools out there. They know what they're doing. Let the pros do it. Access to services. Again, least privileges, incident investigation. Use logs. Logs are your evidence once you're the detective of what happened. Try to be informative. Try to give as much context as possible. If I'll see one more, a problem occurred, and go insane. Libraries, dependency check. And disaster recovery, well, a backup. There's no better solution right now. Hopefully, there will be. Another view of your app and how you do things is we need to understand it's very layered. In today's modern tech, we no longer have an app that's everything encapsulated. We have our code that sits on GitHub. We have our CI/CD pipeline using GitHub Actions. We have our cloud. We have so many different entities that have different problems, and we need to engage them with different tools. Now we'll do a quick demo where I'll show you a simple Python app using Fast API and how I incorporate 7 open source security tools that give us immediate value, easy to incorporate, and easy to maintain, which is just as important. If your solution you're doing is hard to maintain on the long term, it's not really a solution, it's a patch. So which tools will we be using? Well, I assume most of you know Bandit. Bandit is a very common SAST tool for Python. Gitleaks is probably the most exciting tool, at least by my humble opinion. Gitleaks checks for secrets within your code. But the cool thing they do is they don't just check your latest commit, they check your commit history. I think we've all, at least once in our careers, maybe 5 times, have committed a secret. And then we're like, oh, no, what am I going to do? Deleted commit, never happened. No one checks the past commit. Gitleaks does. And that's important because Git always remembers. Beyond them, Kix, a wonderful tool for infrastructure as code, for SCA safety. Containers, Trivy by Aqua. DAST pen testing using OWASP's Zap. And for the MFA check, we have our own custom script. But there are tools out there you can use. We just did what we needed to do. So let's go to the code. So as I've said before, this is a small movie app that tells us information about movies. I'll show you the code, not very impressive, but still, amazing. The point I want to show you here is it's day-to-day Python code, not very good on purpose, that has SQL injection possible issues. We have within our Docker file here exposed secrets. We have buckets that are not encrypted and are public on default. Those are all common issues. You might not have all of them in one commit, I hope, but eventually you'll face them all. So let's see how we handled it. כמה תמונות אתה רוצה ממני? זה מחמיא. ברבור שלי. Okay, back to English. So, show of hands, who here knows, uses, and loves GitHub Actions? I actually expected more, but fine. So, GitHub Actions is a wonderful CI/CD tool that allows you to create actions and use the community's actions, incorporate them into your every single PR. You have a PR, it runs those checks, you get immediate feedback. It's a wonderful and easy way to use those tools. So let's see real quickly, I won't dive into it too much, but what have I done here? So on every single push event, we run the following jobs. For example, SAST. Andrea Pirlo. Runs on Ubuntu latest, the name of it, the steps, what it uses, And the important part I want to show is this. I'm not using some code I sat down, learned, investigated. I use a public action used by a bunch of professionals that know their job, are proud of it, and continuously update it. Whenever you need to choose which tool I need to incorporate, I think the single most important thing, who stands behind the tool? How hard do they work at maintaining it? How much do they care about their craft? I vouch for Bandit. So with every tool, you'll need to understand what it does, how it does it, what does it need? I call it like the floor. What's the base it needs to start building? And the ceiling is, okay, once I've incorporated everything, what's the value? What does it give me? What does it do? Once you decided that it's easy enough to incorporate, it gives you enough value, you start to investigate. Okay, what are the flags? How do I use it? What do I expect to see? You do a local test, you do a test via the CI/CD. Eventually, it gets here. And now let's see what actually happens in our repo. So I have a nice little repo, and I've done an extensive PR with an empty README file, like most ones are. And as you can see, the following 7 checks we talked about ran and obviously failed. So you as the developer, you do your code, you do whatever you do, you create a PR, suddenly you get instant feedback. You don't need to work hard. You don't need to go to another UI system. You don't need to ask someone for permission. It's within your native dev cycle. And let's see what's the actual information we have. So example, let's do a secret scanner, Gitleaks. So we'll see the secret detection, and we get on the STD out exactly what is the problematic line, what does it say, and obviously what should we do, the remediation part. Now I want to pause here and ask, generally, I think we can all agree, incorporating a tool that you've decided on is the easy part. Learning the industry, learning the different tools, start using them and then incorporating it, that's the difficult part. So we need to think to ourselves, what's the perimeters? What kind of plan am I going with into this battle for security? So for that issue, let's talk about our 8 points, and I'll do that quickly, of our security plan. We need to think about our code. Does our code have vulnerabilities? Does it have secrets? Do we have valid logs that actually say something? Our libraries, are they up to date? Do we have existing issues? Your infrastructure, cloud misconfiguration, least privilege remote access. Runtime, pen testing, API security. Your pipeline itself, does it have the vulnerability for chain attacks? Your data, is it encrypted? How do you handle secrets? Third parties like multi-factor authentication, scoped access. Actually, I want to talk about 8. First, your operations, audit, backup. We need to make sure they actually happen. There's a lot of tools that have backup true and truly never backups. And the 7th point is your people. Your people within your dev organization are security assets and hazards at the very same time. We can't just think just about the code. We need to think about the people that eventually incorporate it. If people understand why they're doing what they're doing it better, faster, and with more passion. So let's talk about the experience I've shown you. I think we can agree it was a little bit easier than expected once you know the tool you want to use. GitHub Actions allows us to do it very easily. But it wasn't easy enough. I've done all the studying for you. And you'll do a lot of studying. And you'll have a lot of comparing. And eventually, let's be honest, it will take you something like 3 weeks to decide which secrets tool you want to use. That's a lot of time. It's also very easy to start, but maintainability will always be an issue. You might choose a great tool like Bandit, but you might not. So always try to look like how many commits were there the last, month? How many people contribute? The amount of stars? Try to look at different aspects. And a lack of a centralized data and broad analyze. Right now, you've only seen the results within the context of a PR. But someone else, your CISO, a dev team, someone wants to see a little bit more of a broad scope. He won't go PR by PR, start having some stats in a stat sheet. So this is the pitch part of the talk. This is where we as JIT come into play. At JIT, we do orchestration of open source security tools and try to take all the hassle of understanding what you need and how to incorporate it off your head. You just say, hey, I want to have no secret detection issues. I'm on it. Okay. So thank you so much for your time. I hope someone here was a little bit interested or intrigued. And if so, I'm available in my email. And we're available on our website. And I'm open to questions. And the last thing I'll say before I give you the ability to speak, for way too long, the relationship between dev and security has not been fruitful for both sides. It's been a bit of a war between the two entities. And the people that truly suffer are our eventual clients. So try to think yourselves as the owners of the process and how I can make things better and not just make the PR merge. So thank you so much for your time.
Question?
Yeah, sure.
This is more of a side question, but I'm just wondering if Git, how do you call it? Git action?
Yeah, Git actions.
If it says that you have some issues, it drops the commit?
No. It says that the check failed. Now, you as the owner of the repo or the organization, you decide, okay, for each PR to be available to be merged, all checks need to pass, X amount of checks need to pass. No checks need to pass, that's on dev.
That's a common strategy also.
Yeah. Velocity only. Any other questions?
From your experience, what do you think about Git pre-commit hooks?
I think it's a wonderful tool that should be used by all. I can say that we're working on something a bit extensive on that issue. But in more general terms, everyone know the term shift left? Okay, enough heads moved. The basic idea is we need to move the security aspect of what we're doing as early as available of our development cycle. There's nothing earlier than your IDE or Notepad++, whatever you use. So there are several tools that allow you out of the box to use it. I think it's a wonderful tool. The only question you need to ask yourself, does it really serve the greater purpose? Because there are several tools that run on your entire scan code, entire branch. Sometimes it's better for different types of actions, or if you're trying to detect a potential MITRE tactic attack, which involves many different CVEs. So you always need to be aware, what am I targeting? But a great question. Yes?
There's an issue that bothers me a lot, and I'd like to hear your opinion about placing trust in external tools and external...
Trust no one. It's a trap.
And specifically,
yeah.
There's one kind of thing that where you say, for example, secret manager. So if I'm using a secret manager, that I'm essentially trusting some third party with my most sensitive data.
No doubt.
That's one kind of thing.
Right.
A different kind of thing is your GitHub action was using some code that's taken as the code was shown there from the master branch of some other repository on GitHub.
Yeah.
And that means that when changes get in there, you don't review them before you use them.
Yeah, okay. So it's two different points, and I'll address them both because they're wonderful points. So first and foremost, regarding the master thing, yeah, don't do it. It was a mistake on purpose. Use a specific version so future versions don't hamper you. But good point, always. And regarding trusting third parties. So I've incorporated an external GitHub action into my own CI/CD. First and foremost, GitHub actions run within your platform, so you don't go externally to that action. I always say, check the action you're using. Go over the source code themselves. Sometimes you might see something shady. Don't use it or open an issue. But yeah, a big part of incorporating third party is the element of trust, which requires a lot of investigation. Thank you for the question.